In this video, I'll demonstrate how to add rasters into RStudio and then conduct a few geoprocesses such as clipping it or cropping it to a shapefile, calculating some stealth statistics like standard deviation, mean, and then we'll go into calculating slope and flow direction rasters. That's if you have a DEM. I'll be using a DEM, but some of these other things you can find useful for other rasters. Then we'll go into classifying them into groupings. They're matrices, so we'll just group the different pixel values in the matrix into certain classes, bin them, and then we'll go into masking and remove a certain class or group of pixels, and then I'll add a hillshade and lay one of our other rasters atop that hillshade with semi-transparent call. So hopefully something in here is useful for you guys. We'll start by setting the working directory. All good. Make sure that you have these three packages, the libraries for them called. Make sure they're installed also. So if we wanted to add the DEM, we can go like that. I always like to investigate and make sure that the data that I've loaded in here is exactly what it should be. Know the min and max values, right? It's a matrix, so you want to know some of the details about it. Know that it's projected properly. See what it looks like. Looks good. Then we'll add the shapefile that we're going to clip this to. And again, if you wanted to just look at that and make sure that it has the same projection, make sure that its extent is the same as or is correct. And we can also look at that. Looks good. So now we'll crop, or what we would say as clip in the geospatial world. Crop that raster to add the sample DEM or your original raster there, the focal area there, and crop it, and we'll see what that looks like. Boom, looks good. And you can always plot the shapefile atop of your original or the new raster, and you would just, when you run that plot function, you want to hit add equals true. So now when looking into standard deviation, just use that cell statistics function or cell stats function. We're using the cropped raster, call it SD there. We'll hit that, and then 414 looks good. Knowing that our values are up to about 3600, that looks good. Same thing with the mean. 2208 looks like a good mean, looks appropriate. If you get values that are way out in left field, you want to be sure to address that. So if we calculate slope, we add the DEM here, set that option to slope, and this is all in the terrain suite. The unit we set to degrees. If you just Google terrain, you can see all these, how you would fill all these in. Neighbors equals 8. That means we're looking at 8 pixels around there. And if you want to calculate slope and have it exported as its own TIFF, you can use file name equals and then slope.tiff. You be sure to use that extension there within the quotes, and that'll export this layer into your working directory. So we'll go like that. Looks good. Let's plot it and see what it looks like. This is a pretty high resolution raster, so on this screen at this small scale we won't really be able to see it too well. Also, R may take some time when it comes to plotting things and calculating things, depending on how big your raster is. So look for that stop sign up in the corner of your console, wherever you've placed that. So now that looks good. That slope looks good. As far as I know, those areas are much steeper. So got that in degrees. We could also look at it in Rs. Yep, looks good there too. These areas are much steeper right above this basin. And then we can also calculate flow direction. Be sure to change that option to flow direction. Same original raster. And I'm not going to export this to anything, but you could. So we have the flow direction. It's going to take a minute to calculate that. And then we can plot it. Sometimes that stop sign doesn't go when you're trying to plot things, so you just have to be patient. That all looks fine. So now if we want to classify the raster, we have to create a new data frame. And in this case, here's my pixel values. I know this is the minimum value in this raster that I'm using, the original raster. And I want to set anything below 1400 in this raster to NA, or like no data values. And then anything between 1400 and 2000 to class 1, 2000 to 2500, class 2, and then 3000 to infinity, or anything above 3000 we'd set to class 3. So I'll run that. Looks good. So now we got to take that these classes and create a matrix out of it and ensure that it's being read by R as a matrix. And I always like to look at it, make sure it looks proper. This does look good. Here's our 3 classes here on the right side of that. So that looks good. It's its own object now. And now we can combine the original DEM that I brought in with this new matrix. And we run this reclassify function. So that should be good. And we will view that. And yep, there it is. So these are the no data pixels here. And then we have classes 1 and then 2, and the dark red makes for 3. So that looks good. And this is that, again, that basin, this lower elevation basin. Then we have a lot in between, and then we have some really tall peaks in this raster. So if I wanted to plot this with a color scheme, you can change this color scheme to something that you please. In this case, why don't I make it, I'll use this one down here. So terrain colors, and you can decide how many terrain colors you use. I'll also just enter the colors manually and wait for that to load. It takes a while. So you get something like that. And then if we go to histogram, we want to see the values that we have. We would say, okay, all these different values are here. These are our classes. These are all our no data values there. So if we wanted to plot just class 2, we could. So now we're going to extract just that second class, and there it is. And let's say we wanted to mask that and get rid of it. So by the way, when you're selecting just for one class, or you're just pulling out one class, you use the which function. So let's say now I want to take that second class and I want to create no data values out of it, or effectively mask it out of our raster. So then let's plot that, and we get this. So all of those green areas are now eliminated. So now if we wanted to add a hillshade, we could, I've calculated this in another program, and let's see how it looks. Looks good according to R's standard colors. Let's say I want to plot it on a gray scale. In this case, values 1 to 100, and that would be a spectrum. And I don't want a legend. I'm going to have the main title say Hillshade. Don't need any other axis labels. So we will hit that, and that's what appears. If we were to set axes to true, we would have the text axes, obviously. So now let's add another raster atop of this. And in this case, I filled in the labels, or at least the label places for you. Also up here, we don't need a legend, so set that to false. And we want to add this atop of the hillshade, or that what the plot already contains. Set that to true. Alpha has to do with the transparency, so we'll run this once and see what we get. So we get that. So there's our classified raster minus the second class, right? We eliminated those values. And if we wanted to make that a little less transparent, especially because zoomed out this far, that hillshade, which is pretty high resolution, is kind of blocky looking. So we can get something like that depending on what you're trying to demonstrate. So I hope that's helpful for you. Let me know if you have any questions.